The next question, they tell us the following. They say to us that in this diagram, A is the point -2, -3, B is the point 3 and -4, C is the point 4 and R, and they give us D as 2 and 1. They say those are the vertices of a quadrilateral ABCD. Okay, now remember your quadrilaterals, there's quite a few of them. Okay, so hopefully they're going to give us some regularity here. Let's see. P is the midpoint of the line AD. Now P lies over here, and again I'm going to ask you to use your imagination. If that is P, this length is equal to that length. So if they ask us for those coordinates, it's the midpoint formula quite easily. Okay, so that's the information they gave us. Okay, now they say calculate the value of R, which lies over here, if it's given that AD is parallel to BC. Now, folks, can you see how they changed the quadrilateral? They made it a trapezium now, so it's a particular one. AD parallel to BC, we can say the gradients are equal and then find R. There's more than one way to do that, but it's for 4 marks that they ask this question. So for the 4 marks, we're going to do as little as possible work. They've given us the first part of the question. They said AD is parallel to BC. That was given to you. Okay, so the gradient of AD is equal to the gradient of BC, and the quickest way to do the gradient is to do it in your head. AD first. The y value of D minus the y value of A over the x value of D minus the x value of A. Don't swap the two around. So 1 minus -3 is 1 plus 3, which gives 4 over there. 2 minus -2 is 2 plus 2, which gives 4 over here. So, oh, look at this. The gradient of this line is 1. So now we know also that the gradient of that one is 1. Just information that we need to fill in. Now we go to the bottom line, and that's where the variable lies. R minus 4. So it's R minus -4 becomes R plus 4. Remember the double negative. 4 minus 3 is 1. Okay, now look at that. I've got a 1 on this side. So what do I have? 1 is equal to R plus 4. So what is R? R value is -3. Okay, some arithmetic that we had to do, and we've got it. Now you're going to take that answer and you're going to put it on your diagram in case you need it for later. So here, I'm just going to erase that part, and I'm going to fill in the y value is -3. I now have for 4 marks, all of that work for 4 marks. Quite nice. Okay, the second question, let's look at what that says. It says, what type of quadrilateral is ABCD? Well, I never. It is a trapezium. Okay, now in America, for those of you that use the internet for extra examples, this is called a trapezoid or trapezoid. Okay, it's one and the same thing. It's a trapezium. There's one pair of lines that are parallel to one another for 1 mark. Okay, 3.1.3, in other words, the third question in this one says, determine the coordinates of P. Now we've seen, they told us P is the midpoint of AD. Now folks, put your brackets down and do it in your head. Your theory says that you add the 2 x's together, half. Add the 2 y's and half. 2 minus 2 is 0. If I halve that, I get 0. And we could have seen it over here because it's on the y-axis. So 1 minus 3 is -2. Divided by 2 is -1. So there you go. 2 marks for number 3. 1 for the x-coordinate, 1 for the y-coordinate. Not a difficult thing. It's applying the midpoint formula. The next question. Prove that BP is perpendicular to AD. So if we put an imaginary line here, BP, we want to prove that it's perpendicular to AD. Number 4. How do I prove that? Well, I do have the gradient of, no, I don't have the gradient of BP. I must find it. I do have that gradient. So hopefully this gradient to be perpendicular, we need to find out, is this minus 1? Well, let's have a look. The gradient of PB, the y value of P minus the y value of B is minus 1 plus 4 gives me 3. 0 minus 3 gives me minus 3, and look at that, minus 1. So the product of those two gradients gives you minus 1, so they're perpendicular. Okay, let's conclude that for the final mark here. We're going to say, therefore, the gradient of PB times the gradient of AD is indeed minus 1, and with that, we can say that PB is indeed perpendicular to AD for a good 2 marks. Okay, so the last 2 questions is for 5 marks each. So I'm going to spend some time here. Now, not with the first one. Look at what they're asking again. I bet you saw it. There's a triangle APB, folks. What do you think they're going to ask you? They're going to ask you for the equation of the circle around the triangle. 4th time we see that today. Don't forget this. Okay, so the midpoint of AB is indeed the center of the circle that runs around it, and I can find the distance formula between those two, and it will give me my radius. It's for 5 marks. I'm just going to put the answer on the screen for you so that if you need it or you're doing this problem by yourself later on again, then you have the correct answer with you. And that answer for number 5 is x minus a half squared plus y plus 7 over 2 all squared is equal to 26 over 4. Remember, it's the 4th time we see this today. So I guarantee you're either going to get an area or you're going to get a question that looks like this. Now, the next question that I want to do is part 6 of this question. This I have seen in all, I've done about 12 or 13. I've looked at 12 to 13 questions. 3 of them had this question repeated. So I want you to sit close to your screen, take notes. This is a very important concept. They now say to us that calculate the maximum radius of the following circle, x squared plus y squared minus 2x cos theta minus 4y sine theta. No, sorry, that's cos theta that they give us there. They could have given it us as sine. I'll talk about that in a second. So they say this is cos theta, which is equal to negative 2. Clearly, this is a circle with its center not at the origin because there's an x term and a y term. Okay, now to find the radius, I need to complete that square. So let's do that. Let's do that. I get x squared minus 2 cos theta is the coefficient of x. I'm going to leave some space. Plus y squared minus 4 cos theta y, leave a space, is equal to minus 2 on the other side. Let me just make sure, yeah, the minus 2. Now remember, how do I complete the square? I take the coefficient of the middle term, in this case x or y, I halve it and I square it and I add it to both sides. So if I take 2 cos theta and I halve it, I have cos theta left and I'm going to square that cos theta. The same on the other side. I halve 4 cos theta. If I halve it, it's 2 cos theta. If I square that, it gives me 4 cosine squared theta. Now what I do to the one side of an equation, I need to do to the other side. So I'm going to add cos squared theta over here, and I'm going to add 4 cos squared theta over there. And folks, we know that that is our radius. Now, before I continue, if they gave me that second one as a sine, you have a way out of it. Sine squared is 1 minus cos squared. So you don't have to work with both of them. You can change it to one of the two ratios. Okay, let us have a look then at the rest of this question. It's an absolutely beautiful question. Now they ask us, what is the maximum, I'm going to do it in green, the maximum radius that this circle can have. So what is the radius? The radius is 5 cosine squared theta minus 2. And they're asking you for the maximum value. By the way, that's r squared. It's not just r. It's r squared. Don't forget that. Okay. So they are asking us to find the maximum value of 5 cos squared theta minus 2. Okay. Now let's see how we argue this. We're going to start with something that we know. We know that the cosine of theta lies between 1 and minus 1. So cosine has a minimum of 1 and a minus 1 rather, and a maximum of 1. Now if I square it, remember if you square something, the only thing that happens is it jumps to the positive. Okay, so if it was minus 3, it's now positive 9 because I squared it. Okay, so that means that the cosine squared of theta must therefore lie between 1 and 0. Okay, so there's 2 more steps left. Now, I've started with something that I know. Diagram. I know that my cosine graph does that from 1 to minus 1. That's where I started. Then I squared it, so that went to the top. So I'm talking about that thing that has a minimum of 0 and a maximum of 1. But I didn't want just 5 cos squared. I wanted 5 cos squared. How do I make a cos squared a 5 cos squared? I multiply by 5. What I do to one side, I need to do to the other side. Okay, so therefore, 5 times 0 is still 0, is smaller than 5 cosine squared theta, which is smaller than 1 times 5, which is 5. So I actually brought this in by timesing here. I timesed with a 5 and I got my next line. That's still not what I wanted. I wanted 5 cos squared minus 2. So what am I going to do? I'm going to subtract 2 from every side of that inequality. So finally it becomes, if I minus 2, 0 minus 2 is minus 2. 5 cosine squared theta minus the 2. 5 minus 2 is 3. And there's your maximum. Your maximum radius is 3. Your minimum radius will be negative 2. Okay,